For the start, for those who have not interacted with me, I am called Aloysius Oraku. I'll be the one who will take you through this particular module of geographical information systems. And what we're looking at today is the introductory part. We'll be looking at the introduction to GIS, but also look at its overview, look at the application, where we can be able to apply it. I found when someone was asking whether it is applicable in businesses, whether this is actually a module that is applicable in all the various sectors that most of us will belong to. We'll be able to give you a broader sized application mode, but also we'll want to focus on demography and reproductive health somewhere. But even for those who are business people, those who are into agriculture and so forth, this is a place that you should be in. So to start with is that we say the geographical information systems, these are a computer-based tool that is designed for capturing, storing, analyzing, and visualizing spatial data. And we're saying this technology is mainly used to collect, manage, and analyze data. So it's more of a tool for analyzing geographical information, but also for collecting it. And the digital maps that are in the geographical information system are more valuable because they contain more applications, but also more information, and they provide deeper data that is more spatial. When we're referring to spatial data, we're looking at data that is more disaggregated than the ones we would find in a map that is drawn on paper. So, for example, on a paper map, you might just have physical features, but the geographical information systems provides you more accurate data, more from the physical to information that is, say, that is more systemic. It may not be physical, might show you how the hills are, how the plateaus are, where they are, the movement of the rivers, the lakes, and so forth. So we're saying that this data, in terms of demography, has more multiple uses, such as in census records, survey data, and remote sensing imagery to provide a special perspective on demographic and health-related issues. So the overview is that it integrates and displays geographic data, but also it has interactive queries for mapping. And it can be, like I have said earlier, it can be applicable in agriculture, in environmental impact assessment, in urban planning and logistics, but also for those in business. So we want to look at its application, and we're saying that in demography, that the GIS plays a very critical role in understanding population distributions, health service accessibility, and disease patterns. So, in this GIS, you're able to understand how population distributions impact on service delivery, on disease patterns. So if you have your population distributions into this GIS, then you're able to predict, or you're able to analyze specifically how diseases, or how the disease patterns are in your area. It can also be used to understand the levels of service delivery, in terms of where is the population concentrated and where are the services. For example, if you had your geographical overview, and in that geographical overview, in the geographic information systems, you have the specific positions of households. in terms of how the households are positioned, then you would be able to understand the variability between household placement and where the health facilities are. And then where the health facilities are, then gives you an overview of how long these people can take to access those health facilities. It may not only be health facilities, they can be every other services such as education facilities, such as say business facilities like where the trading centers are and so forth. So these are some of the relevances or some of the applications where this can be done. Another relevance in demography is that it helps us to map population distributions and growth patterns. So the GIS enables visualization of population density, age structure, and growth trends. Uh, at a later time, I'll be able to open for you one of the GIS tools that I currently use in analyzing some of the information that I have. It is called Quantum Geographical Information Systems. So, if some of you have interacted with already some of these quantum geographical information systems, kindly use the message place to type some of your experiences as we go through this lecture, so that we'll be able to understand deeper that some of you already have experience, and later during this module would want to some of you to share some of the experience that you have in using this specific tool in making your work easier. We're also saying that it helps in identifying health service coverage and gaps. So by mapping the location of hospitals, maternity clinics, and reproductive health services, GIS helps identify underserved areas where health facilities are insufficient or inaccessible. So this supports strategic expansion. So in service delivery, you take services to the people. You don't you don't let people come for services. So through this GIS, you're able to identify where facilities are away from populations, and therefore you're able to position these facilities to underserved areas. But also, we are saying that these tools help us analyze spatial patterns of, of fertility, of mortality, and migration. So the geographical information systems, which is GIS or GIS, allows researchers to visualize and analyze regional differences in fertility and mortality rates. These may not only be regional, even for colleagues who are already into employment, you're able to look at your information at a health facility level. Say you're looking at you're looking at the family planning uptake within your health facility catchment. So if you visualize the different types of family planning that the mothers are coming for, or for the gentlemen are coming for, uh, then you're able to understand uh, which households or which population distribution caliber takes which kind of family planning. So you'll realize that in a village A, actually they consume more of condoms than say implants. So then you will be able to realize that actually in village A, maybe they don't allow their women to take contraceptives, and that is why the men are opting for condom use. So then it gives you an idea of the interventions when you or when you analyze this better. But also it can help you track the migration patterns, which then aids on understanding how urbanization affects reproductive health outcomes. So this in our aspect of demography and reproductive health. So if you, as we're going through this particular lecture, if you have any other questions you would want to ask, kindly drop them in the message. At the conclusion of the lecture, we'll be able to handle some of those questions that you have there. And lastly, for the relevance of GIS, we're saying that it helps us understand environmental influences on reproductive health. So, for those who are not specifically looking at reproductive health, some of you who are looking at issues of public health, some of you who are looking at businesses, some of you who are looking at, say, issues related to nutrition, some of you who are looking at issues of livelihoods. So we are saying that it can help us understand environmental influences to these different sectors that we're looking at. In environmental factors such as climate change, pollution, and sanitation can impact reproductive health, they can impact businesses, they can impact several other issues. So we're saying that GIS can be used to analyze the correlation between environmental hazards and maternal health outcomes, say, helping authorities mitigate risks in high exposure areas. So through the GIS, you're able to realize places where, say, pollution is more prevalent. You're able to analyze places that do not have very many sanitary facilities. You're able to realize places that experience certain levels of climatic change or different levels of climatic conditions. So through those mappings through GIS, you're able to correlate that probably the climatic changes in or the changes in climatic conditions in these locations and then impacting health outcomes and then impacting reproductive health outcomes. And this is a very relevant uh, aspect in the use of GIS. So at your health facility alone, if you start finding that there are certain health outcomes that are not common in the society, then you're able to map some of these health outcomes to, using the GIS, you're able to map some of these health outcomes to the GIS analysis that you have. So then we would want to look at the future of GIS. Yes, so we're saying that we now want to look at the future of these geographical information systems. And one is that there is an increasing use in public health, defense, agriculture, urban planning. So, as a student who is going through this lecture today, you need to be open and practical to understanding the current trend of geographical information systems. And this is one of the skills that you can learn today, because people in the defense or those who are the security personnel in defense are using the geographical information systems to understand how populations are positioned, how households are disaggregated, but also they're understanding how the issues of forests, say, the natural the natural appearance of a location. So then they are able to build their barriers and understand how enemies might attack or how they can be able to attack certain places. So this is a very diverse element in our current world today. But also we are having the growth of local-based services. We are having mobile devices tracking nearest facilities. We're having integration with smart cities. So what we are seeing is an upgrade of GIS, but also we are seeing the trend is not going down. And therefore, casually, what does this mean? That in your current practice, you need to interest yourself into the issues of geographical information systems, because then you're able to have better data capture. Because you're capturing data with the different codes, and if you're capturing data with geographical codes, then you're able to collect real-time information. And through real-time information, it makes decision making a little bit easier and better. Then you'll be able to make evidence-based decision making. We also want to just go through the quick history of the GIS development. And we're saying that initially we are using geographical records, say cave paintings. We have in the Christian literature, we had people who were using tablets, not the tablets that are right now, but tablets that were written out of rocks, out of leaves, out of skin tidings, and so forth. But then after John Snow mapped the cholera outbreak in London, then there started coming the spatial analysis, where they started mapping different cases, individual by individual, going deeper. So, say for example, in Uganda, there is already the ministry already declared an Ebola outcome. So what do you need to do? You have to map. You have to map locations using these particular tools, where you get your first suspect, then you start questioning and doing tracing. And for you to be able to do this suspect tracing, then contact tracing, then you must be able to have some of these tools and understand the geographical movements of these individuals who are your index cases. So in 1962, we have Dr. Roger Tomlinson developing the first operational GIS called the Canadian Geographical Information Systems. And these Canadian Geographical Information Systems contained information about the geographical information of Canada. So, in other words, you're gathering all the geographical information about Canada to help you analyze, predict, and be able to make informed decisions. But in 1980, we saw an upgrade, and we saw the GIS become commercialized with software such as the SRIS, ARC, then the Info GIS, Quantum GIS, and then the Info GIS. So you have very many versions of the GIS. Uh, and you can only use the version of what you want. So there are actually very many of these open source GIS software. You have even the grass, you have the UDIG. So in your free time, you should be able to go through and check some of the cloud-based GIS, some of the mobile, some of the open source and the proprietor GIS. So the proprietor one would probably cost you some few dollars, but there are those that are open source and you can actually use them for your data analysis. So here in 1980, when the ARC or the ESRI GIS came, this is actually a mobile version. You will then be able to to buy this version. It became a bit commercialized. But in the 1990s and the 2000s, this version of geographical information systems became a standardized version, and therefore it was internet enabled. Initially, it was capturing information which you would enter physically, but with internet enabled, it was a bit easier for people to synchronize information and have all their geographical information captured and linked. So, what are some of the components of these geographical information systems that you're all hearing about, for those who might be hearing about it for the first time. So the software provides tools for data storage, analysis, and visualization. So we have ARC info, map info, but also there is the hardware, which is the computer servers and the GIS operations. Like I said, at the end of this lecture, I will be able to share with you one of the the GIS tools, which is the Quantum Geographical Information Systems. Then we also have the data, which is the spatial maps, the satellite images, and the tabular. So these components of the GIS, these are already components that are entrenched into the geographical information systems. We even have the GIS professionals and analysts. Now, these are people who are using the systems like you and I, who are already using the GIS systems. Then we have the techniques and the workflows for GIS applications, which is how you can operate these systems. So mainly what is not physical is the data and the software, but we also have what we call shape files. These are now the files that contain all the mapping, the satellite images, and the tabular. So in the geographical information system software, we have systems that are commercial, and the commercial systems include the ARC stroke the info. We have the Intergraph GIS. We also have the Map Info GIS. Then we have what we call open source, which are geographical information systems that are not charged, and these are what we call the AMS and the MARS. But also we have the QGIS, which is the quantum that will be able to have an idea and be able to see. We have the features that have database management, spatial analysis, mapping tools, and visualization. So these are features of the GIS software. We have the hardware, which requires high performance computers. So for you to be able to download these geographical information softwares, you should be able to have a computer that is high performing. But also we have examples of ARC Info, which is a desktop 9.0 specifications, and you need a cooling system. We need a CPU. We need a RAM. We need a display, storage, and internet access. Of course, these are key hardwares. Internet access might be there for those that are using the commercial softwares, but for the open source, you may not need internet during operation. We also have the GIS data, which is the special data that has the maps, the tabular data, that has data that must be properly georeferenced. Then we have what we call the GIS users. And the GIS users, like we said earlier, these are the GIS technologists who use this information, who use this tool. We have the users who range from technical to non-technical professionals. And the non-technical professionals are people who are sub-using this information that has already been generated for them by the technical professionals. Then we have a user-friendly interface that allows easy access to the GIS tools. So just to go deeper into the types of the users, we say there are technical users, end users, business and government professionals. But even us who are students, we are end users who would want to use this information and then to be able to move through the studies that each one of us is going through. So this is an important tool that can help you analyze your information, but also for decision makers, can help them make informed decisions. For those who are going through their business, you're also able to pick this information and apply it in your planning, in doing risk mapping, in doing disaster management, and research as well. So, what are some of the methods in GIS? These some of us will just look at it when we are looking at the practical aspect of the QGIS. So, some of the major functions of the GIS include the input, the manipulation, the management, the query and the analysis, and then the visualization. So, data input in GIS, data sources include the digitalized maps, the satellite images, GPS coordinates, we have the tabular data. So this is when you're entering information. And then for you to do conversion, you can do vector and raster formats. Then there's manual and versus automated. So this is briefly the expert kind of introduction that we wanted to have for this QGIS, for geographical information systems. So for us to have a more practical feel of this particular lecture of introducing geographical information systems, and for us to be able to understand it when we are having interactions, I would want to close this PowerPoint presentation and share with you a screen having the geographical, the quantum geographical information systems that I am using to help us understand better the geographical information systems. Yes, we'll be concluding in a bit. I hope you're now able to see that screen. Majok, you were saying you're not seeing the screen. I hope you're able to see that screen.
It's clear.
So that is just, yes, this is just a brief. If you're able to see up here, this is what we call the quantum geographical information systems. And these are some of the works that I have been doing to analyze some of the information. So you're seeing here that we're using a lower level schools for study. We wanted to understand some of the practices in lower schools. So I'm just taking you through. You're able to see some of the features we were talking about. This is the vector feature. This is the raster feature that we were looking at. So if I wanted to start a new, just to take you through on how this works, I must already be having what we call shape files. And these shape files are the ones that that are already existing, and they already have what we call uh, satellite information. They already have the maps and so forth. So let me look through and see if I already have some of those shape files that have data that is from the satellite. So let me just look through and see on my desktop if I have something related to quantum geographical information systems. Okay. Program files. Okay. Well, maybe I do not have it here, but let me check my shape files. So sometimes you may not have shape files, but you can always have these shape files downloaded you can always have these shape files downloaded on the internet. There are very many shape files that you can have, but I have been told that I have one here on my desktop, so I am just looking for it and we'll be good to go. So I want us to have a practical feel of how the analysis would go. You would be able to see some of the maps. My current shape files. Okay, maybe I can drop that here. Okay, so you see, just a moment. I see some of you already seeing something interesting, but I'm using data for Uganda. So what happens is that this information is already in my folders, and where you're seeing something called browser, in the browser here I am able to access my screen, my laptop screen, and I can go to wherever that folder for the shape files are, and say the folder is already in the desktop, and I can go to desktop and look for it. Current shape files you're already seeing here. Then it has shape files for health facilities, it has shape files for sub-counties, it has shape files for villages, the districts in Uganda, and so forth. So if I double click, or if I open this to the version of the QGIS, the Geographical Information Systems, it's able to offer for me that, and I double click. So when I double click, it comes here. And here now I am able to showcase what I have. And you're able to see here that this sub-counties 2029 already shows you all the sub-counties in Uganda. So if I have information on all the sub-counties in Uganda, and I did not want the entire country, and I wanted to say I want to pick a specific region, of course, I'm just trying to show you, not necessarily taking you through how the GIS works, but I'm just trying to show you how it can actually analyze information. So instead of looking at the entire country, I would want to say I want to look at Koboko, which is the nearest district that is bordering South Sudan. So I would analyze that, and I would leave it that at that, and come here and save the district called Koboko, and just analyze information that is specific to Koboko. Just the same way I was telling you that you can actually analyze information that is specific to your region. So you would now see here, then come to your vectors and be able to analyze any other issue that you wanted to analyze. So I can say, let me show labels, and I'm showing every sub-county in this in this place called Koboko that borders South Sudan. So then, if I also wanted to go ahead and have health facilities in this specific area, I would still have them. So you would have in your QGIS, you see, it is showing for me health facilities in the entire country already. So you're able to see, if I zoomed here, you're able to see health facilities for the entire country, and even including those ones that are within here. So this is just the brief of what you can actually do with this QIGIS. And it has very many of the information that you're able to see here. It has a ANC fourth visit. You're able to see it has ANC fifth, fourth visit. So then you're able to look at which facility had which people coming from which specific village for this particular antenatal care. And that is the brief that I would want to give you regarding introduction to geographical information systems. And I would want to end there for today. Unless we have any questions in that regard, then we can have them and we will start there tomorrow, same time. Thank you. Yes, Majok.
Yes, good evening, everyone.
Good evening
You are
to you.
getting me? Yes. Thank you for.
Loud and clear.
Thank you for going through this course. I appreciate. I understand some concept. However, with this recent OGIS that you have just presented, it is actually a good software, but the question is, can it be applicable to even places that has no like real time data? For example, I'm in a will. If I'm able, can I be able to look at like fourth visit antenatal information?
Yes. Thank you for that question. I can have all the questions at once. If some other people have their questions, you can ask them. Then I'll be able to respond to them in due time. Okay. Yes, Thor. Your hand is up.
Okay. So my concern is just about the session which was conducted yesterday, because I was told that there was a session which was conducted yesterday at 5 exactly at this time. So I didn't attend that session. Could you kindly really share for me the models that you tackled yesterday? Because I did not attend yesterday. So that's my question.
Okay. Any other question?
Let me respond?
Yes, Garrison. You are one.
This is Samuel.
Okay. Yeah.
Oh,
yes.
yeah. That
Oh,
student
sure.
was asked about yesterday's lecture. It was a business lecture, and please, it was uploaded to the platform, the same platform you've used to log in. That is Graphy. If you have any challenge, you can reach out to me either by WhatsApp. I'll be able to direct you. But the content is already uploaded. The graph. Go to Graphy
Okay.
or Research Academy, and then you go to Business Administration. You'll be able to access it.
Okay.
Thank you, Samuel, for that response. So I think the other question from Majok, just to respond to your question, using this specific tool, you can actually be able to get that real data that you're talking about from the health facility that you're dealing with. What you need to do is to create an Excel sheet or a CSV on the same. And then if you already have the mapping, what is very important is that you need the geographical information systems. you already have the geographical information that is already captured about the coding. Like what I already had, I already have the mapping, the geographical mapping for Uganda. So what I will do is to isolate the health facility that I am working in and be able to upload it as an Excel sheet. So if you are able to upload it into quantum geographical information systems, it will be very easy for you to analyze that information. So yes, actually QGIS can help you get real-time information. I've seen a comment in our messages that would request for one comprehensive lecture rather than making it bit by bit. Data is too expensive and someone may not be able to afford daily subscription for data. So let us have this discussion with Samuel. Samuel can take that feedback, and then that is more administrative, and therefore I think he will handle that feedback himself. So maybe to conclude is that I just wanted to have an introductory part, but also a more practical aspect of geographical information systems, so that when we're having a discussion on geographical information systems, how relevant it is for demography, how relevant is it for reproductive health, you're able to have an idea of some of the tools that we are talking about. And therefore, that is why I just ran through that tool that is called Quantum Geographical Information Systems. Otherwise, I would like to conclude there and thank you for attending this specific lecture and wish you a very good night and see you then tomorrow.